So here's a summary of some complexity-related concepts that I myself encountered when I started uh, learning about these things in my own in the context of my own research. And so the three bears here, they can also be metaphorical to my journey, where I was first feeling hesitant about what these things that I discovered about conventional methodology, what they really meant. Then I entered the playing phase, hoping that really this isn't true, or maybe that I hope that this really is true, and then ending up in the last phase where I feel both shot in the chest, but also embracing these new perspectives on data that and research problems that are not as straightforward as I would have perhaps preferred them to be originally. But you can look up the paper if you want more information about this in the behavior change research context. But we will take a sort of an overview on what's meant by these three points more generally. So our first simplification, remember that we were talking about simplifications that often made in social sciences. So it's about the independent versus interconnected observation. And you remember we talked about fat tails. Maybe we can talk about horizontally challenged tails, but the thing is that how they arise is that if you have independent observations, you get this very nice bell curve shape. So that means that some observations, some events are quite big, but and most events are somewhere in the middle, and these extreme events are become exceedingly impossible as you go farther and farther into the tail. And the reason for that, as I said, is that these things sort of all the influencing factors they sort of balance out. Whereas often in the case of complex systems, what you have is a situation where you have one event that causes another event that causes a third event, and it becomes sort of multiplicative. So you lose when you don't have the independence that the events and the factors that are causing them are not independent, then you can discover a lot of these more heavy-tailed or fat-tailed phenomena. And just to remind you of how we described pandemics against the traffic deaths, and how in the case of fat-tailed distribution, you can expect even more extreme events to happen. So what Bent Flubia called the regression to the tail instead of the regression to the mean, which is commonly used as a term for these observations that are independent and in a Gaussian or normally distributed. And we also saw the illusion of stability, so that when a phenomena starts becoming more and more fat-tailed, if you keep the standard deviation the same, you start getting more and more these normal events, but the distribution, the tails of the distribution starts flattening. So you feel more and more secure, like Nassim Taleb's turkey, or Bertrand Russell's chicken, or the example of the Christmas ham that I mentioned. Even though the extreme rare events are becoming more and more dangerous. And this is obviously what happened in with the COVID pandemic, and there was some of these people who have been working with these things for a very long time made a note of this already in 2020 January.